Assalamualaikum and hi everyone, welcome to my video. As for today, I'm going to teach you guys on how to create a project using a software which is called Tinkercad. So the project that we're going to create today is a memory test game with an Arduino. Right, so let's go. So once you have go to the Tinkercad website, so this will be appears on your screen. Right, so if you guys already have an account for this Tinkercad, you can just sign in to your account. But if you guys doesn't have yet, so you can just click join now. Then you can select, are you guys an educator, are you guys students, or are you guys you guys want to create this account for your personal account, right, for your personal project and so on. Alright, so once you have entered your Tinkercad account, your dashboard will be appears, okay, just like this one. Okay. Sorry. So once you have entered here, they will show you guys what you have done for your project. For example, this is the 3D design. So you can see I've created a lot of I've tinkered a lot of other people project so that I can use them and add it to my project. Alright, so we are not doing 3D design today. We were going to create a circuit, okay, a project circuit. So how do you do it? Just go to this create new circuit here. Alright, so just wait. Okay, this will be appeared. Okay, so what you can see here, the component is on the right, but when you click it, the create new circuit, but there is no component on your right. You can see this, there's an arrow on your right side here. Okay, you can just click it. Alright, so they've given you, actually the Tinkercad has a minimum of few components that they can be used. There is not all the component that's been given by the Tinkercad. So basically, not all of the project can be created, but lucky for us, our project can. Alright, so they have a basic component that is actually been used, and also we have all the components. So we have select all the components here. They will separate it to general, they will separate to input, and then they'll separate to output here, and they separate to power and so on. Alright, so we can also see that there is a starter here, which is a starter is there's a simple construction circuit has been created for us so that we know how the components works, how to write the codings, how does the circuits works, and so on. Right, so we will create a project today. So for this name, which is Stunning Bruticus, we can change it to memory test game. Alright, so as you can see here, we will go back to basic. Okay, so firstly we will going to use an Arduino. Okay, Arduino Uno. Then we will use two small breadboard. Okay, just pull it, once you click it, just pull it to the left side. Alright, so then we will use 4 LEDs for our output. Okay, just zoom in again. So we have 4 LEDs. As you can see here, so the LEDs actually all the same colors, which is red. So that's quite boring for a game to have one colors. So how to change it? By clicking the LEDs here and just change the colors. So we're using green, we're using yellow, blue, and also red. Alright, so as you can see, once we created this software, so we don't actually use a resistor, but we just added a resistor so that we know when we want to create the real project. Alright, by buying all the hardware components, we know which part of the component that we want to put a resistor on. Right, so the value of resistor can be changed also by changing the to ohm, and the usual resistor used is 330. Okay, 30. If you can see closely, when you change the value of the resistor, the color on the resistor also will be changed. Okay, so 330. Alright, so just place the resistor to the anode. Alright, okay, we can see a mistake here. So the second part of the pin of the resistor is not connected or inside the socket. So what we'll do is just press the R on your keyboard. So press the resistor and press the R. So it will rotate the components. Right, so let's do for the rest of the resistor. Okay, put it on the anode side of the LEDs. Okay, Right, and lastly, space a bit and put it on the anode side of LEDs. Okay, so now we have done for the output of the LEDs. So we will use a button, which is a push button for the output or for the input of our LEDs. Right, for once you pull or put the push buttons, make sure that the pin or the pin of the button, which is from the left and right side, is not connected to cathode and anode side of the LEDs on the socket, and also the resistor. Right, so it has to be all alone in this knot or sockets. Right, just add another 3. Also, the push button or all the components can be named. Right, just click here, can just name the components. Alright, and then for the last component that we're going to use for today is LCD. Alright, so we're using LCD 16 by 2. Alright, so we have done all the components, so we can close this part. Alright, so we want to do the wiring. So the wiring is actually simple. Just click from the component to another. You can also use this you can also wiring it like this one, but for me I like, or I don't like it, because the wiring when we have a lot of wire, when we just directly put it to the component, it will look messy, right? So I just want to know where the wiring is actually connected. So for me, I like it to be arranged. So if you can see, if I put it upwards, you can see the blue line, so which means that the wire is actually straight from a component. Okay, so make it straight, so you make sure they have blue line, then pull it down. Alright, and then just pay it to the component. Or maybe for example you want to click here, then here you can see once you click, the wire will be your wire can be moved, right? So like this one. So what you want to do, you can also just backspace it if you just miss push the your button on your mouse, and just put it on the component. Okay, so for me, I'm using a ground as a black color and the red for the power. Okay, so let's make it short. I will simply create all the wiring for you guys. Alright, so once you have created all the wiring or connected all together to the component, okay, so you can see here, so the black and red is for the power supply or the ground. Okay, the black is connected to the ground and the red is connected to your power supply. Okay, for the next ground here, it's connected to your second breadboard on the top side of your breadboard. Same goes to here, we already put one resistor and it's connected to the bottom side of the breadboard. Alright, so all the pins is connected. Okay, as you can see here, we put the wiring here, which is pink color, to the D13 from the Arduino. Is connected to the resistor and will enter the anode, the LEDs. If you just put directly to the LED, the LED might be explode, but as we said earlier, this is an software, so if you put or not the resistor, nothing will be change. Okay, same goes to blue here for the blue LEDs. I just change the color of the wire so that I can see what type of component is connected to the Arduino and which component is used. Right, so yellow for the yellow LEDs and the green for the green LEDs. Right, for the orange is connected for the buttons. As you can see, for the button, I've already connected on the top side, on the left top side of left side. Then I've connected from the bottom side of the left side. So for the push button, the wiring, the pin for the button is connected left and also right. So the left is actually connected together. You can see terminal 1A and then terminal 1B. Then when we push the button, then this left side will be connected for the right side, which is terminal 2A and B. Alright, so there's the component, there's the wiring for our bottom side here, which is LEDs and also push button. Now we can see the LCD. So the LCD have ground. So when you guys do the wiring can also be put directly to the LCD, or you can also just put it here, because when you put the LCD, it's already been connected to the socket of the breadboard, right? So we have ground, we have VCC. Alright, when you have connected the VCC here, you can see the green color here, there, which means that all of this socket is actually connected together, which is to the power supply. Right, so we have contrast, which is directly to 0 because we want to see the output given by the LCD. And then we have the RS, register select, which is connected to our A5. You can see the brown color here. Alright, so RW is connected directly to 0 because we want the LCD to read the code, not to write. Okay, if we put 1, we mean that this is right. And then we want to enable is connected to the A4. You can see the pink color here. So it's actually connected to the analog side of the pin on the Arduino. Then we doesn't use the DB0 to DB3, so we just connected directly to ground. And the rest of it, we just connected to the DB4 to D7. You can see the color of the wire is connected to the directly to the Arduino pin. So you can see, you may ask why then I'm not just connected the register select and enable to the pin 1 and 0 here. This is because that pin 1 and 0, TX and RX, is actually pin for transmit and also emit the data, okay, from the Arduino and to the Arduino. So I may not want to try to change it, so I just use another pin on the Arduino, right? So, and then we have the anode LEDs, just put the resistor, and also we have a cathode LEDs for the LCDs. Alright, so once we have done all this wiring and construct the component, so we actually are halfway there to create this project, alright, to create this game, so we can play it later. So once I have done all this, construct the circuit, we will show you how, the code, right? How to write the code. So you can see here, we are using Arduino Uno R3. So, and then if you guys can do the coding on the block, you may, right? But for me, I'm using text so that I can easily know which type or what the program does or how does the output and input runs. Alright, so just cancel this. Once you have put your own components or project, they will just give you guys that code. So it's a simple coding for you guys to activate the LED and also turn off the LEDs. But for the coding, I've already uploaded to the GitHub, right? So you can just copy it. Okay, just copy all of it. Or if you guys can change it a bit, so make it more interesting, you may. So the coding, I will put it on my description. Alright, so let's see a bit about the codings. Right, so the title of our project today is Arduino Memory Test Game. So it's programmed by me, Wanafif Hilmi, and created on 22 November 2020. Alright, so this coding actually will be read by our Arduino here. Right, so Arduino is actually function is to actify and then active flow the output or input. So when we use other coding, other component, which is for example LCD here, so we have a program or code for the LCD to be run, so we can put it in the Arduino. So we just put this liquid crystal library here, which is #include liquid crystal. Okay, so the inside bracket here is actually the pin that we connected for the LCD. Okay, so make sure when you write the pin, make sure it's from the left to right. For example, RS, RW, enable until DB7. So as you can see here, our RS is actually for the chocolate color wire. It's actually connected to the A5. So that's why I want you guys to have a different color for the pin. Alright, so then we're using a void setup. So why do we use void? So void is actually a function for the C program, so that we doesn't have any value to be saved for the function. We just return back normally for the next parts of the program. Right, so firstly the setup. So you want to set up a pin 13 until 10, which is 12, 11 and 10, which is our pink, blue, yellow and green color wire, so which means it's for the LEDs. So we want to put it as an output for this project. And then we set the pin mode of 9, 8, 7 and 6, which is orange, turquoise, purple and brown, which is for the input buttons for the LEDs. So while using input pull up, which means that we want to set the pin as an active high. So that's why we connected all the second part of the pin to the ground. If you want to put it as an active low, make sure that the second part of pin is connected to the power supply, right? So we're using a serial begins so that we can see what's the output in the serial monitor here. And the random seed is just to generate more randomness with the random of the output function. Okay, you will get it later. Then the LCD, so which means that we are using an LCD 16 by 2, so we have 16 characters and we have 2 lines. Then we set a cursor, which means that 0 here is actually from the left side of the LCD, so there is no space, so just they will write welcome to the on the first line, which is 0 here, and then there is no space, so which means they will display on the left side. Then we have 1 here, which is we have 1 space on the left side, and 1 here is for the second line of the LCD. Then we will have delay 2000, which means that we have a 2-second delay, and it will clear screen and go to startup function and success function. So what is startup and success function? Let's go to the startup function first. So startup function is just a countdown, so which means that we want to give the value, the player a 5-second head start, right? So we will just start in how many seconds? With 5 until 1, give a 1-second delay. Alright, and then after it goes to the startup, it will go to success, which means that it will display your score and also the your player or user high score, right? Okay, so then just generate this one. So our size of output, which is the value of LED will be light up, is 1. Then your high score first will be 6, and your high score your life is 16, right? So the value is, or the maximum value can be stored in our output, okay, is 250. Alright, so we will say that the button 1 is actually bold, right? So void loop, so which means loop here, so the coding will be run until we stop the project or reset the project. Alright, so for this part, it's actually for the LED to light up, which is active high here, okay, digital write high, and then 0.4 second, and then active low, turn off the LED for 0.2 second. Right, so what you can see here for the random numbers, see add by 1. So which means that random number, for example 1 here, is add by 1. So add by 9, so 1 add 9 by 10. So the digital write for 10 is a green. So the serial print or the serial monitor here will be print green. Right, same goes to 2, 3 and 4, or yellow, blue or red. Right, it's add by 9. So all of these pin will be active high and then active low. Alright, so and then we will go to the push button. Okay, so the push button, for example, if the ARR equals to 1, so which means this is green, so we will, the button 1, which is digital read 9 here, yellow or orange color, will be different with others button because we will press it, right? So make sure when you name it, it has equal here to the pin, which pin that you want to name it, right? Same goes if you push the wrong right button, your size will be increased. Okay, same goes to for yellow, okay, AR2, AR3, and random numbers 4, which is red. So for 2, make sure that your button 2 will be pressed, AR3 button 3 will be pressed, and AR4 button 4 will be pressed, right? If not, or for example we press the wrong button, our life will be reduced, okay, from 16 here will be reduced by 15. Okay, so once it goes to life here, it will goes to extra, right? So extra, go to extra function. So extra function just to display our remaining life of the player, right? So you will have how many life left, right? And then just numbers here, and then goes live here. So we have only 1 second delay. So the star here is actually how many life that you have. Okay, you will see it later. Alright, so if there is no life left, if it goes to else equals to false. So what does that mean? You guys will understand later. So as here, as before this, we just say for true. So which means that there is true, which means the game will still be running. So it will print on the serial monitor success, and the size will be increased, right? And then go back to your success function is just to display your high score and score. If not, which is there is no life left, s equals to false, we'll display game over, and then return back size equals to 1, life equals to 16, and s equals to true, and goes to finish function. So finish function is actually here, so just display game over, and then you lose. So remember 3 and 4 here is the space from the left side, and 0 is the first line, 1 is the second line, right? And then go back to startup and success function, right? So 16 life is actually quite long, so just use 3 life for you guys to see. Then here 3 life. Right, so let's try to run the program. Alright, as you can see, welcome to the gaming system, the startup. And then it will give us a 5-second head start, so just be ready. The output given by the LEDs. So the blue color is light up, so just press the button in the blue one. Oh. Right, so our score increase and your high score will be increased, and then the next button, which is red, and then yellow, then your high score will be 2. So for example, red, blue, and yellow just now, so just press green, for example. Then you can see the star is equal to 2, and we have only 2 remaining life. So for example, yellow, green, and then so we have another 1 life left, and then yellow, green, green, so just press yellow. Game over, so you lose. Then we go back to startup function, which is give us a 5-second head start. Then go back, this display your score and high score, and your high score just now equals to 2. So we can also be cheated, which is by using this serial monitor here. So you can see the size equals to 1, which is just now, so the color is equal to blue, so just press the blue button here. Then 2 size, so 2 output will be given, so the color is yellow and green, so press yellow and press green. Then it will be increased, so basically this is just cheated, so green and blue, blue, so just press green, then blue, and then blue. So your high score will be 3, and you can see it also in the serial monitor here. Okay, I will enlarge it. Right, for example, green, blue, red, and then blue again. So green, blue, for example, I press yellow, so life became 2. Then it will print again, success, and then 4 output, because we doesn't have to succeed it. So just press yellow, 1 life remaining, right? So yellow, red, so just press yellow and then blue. So game over. So you can see the serial monitor displayed game over. You can also just clear the previous output, just press clear here. Right, so go back again, 1 size, okay, green color. So you can just basically reset again, so just press the red button here, okay, you go back from the top, and your high score will be reset again. Okay, you can see it first. Alright, so you guys go back to 0, or you can just stop simulation. Right, so we have done all the project. So how do you guys want to save it? So just by click this Tinkercad icon. Alright, as you guys can see it, so we can just delete this one. As you guys can see, this memory test game will be created 3 minutes ago. Right, so basically it's in private, so you just can send it to properties, so add in the description, so a game for user to train their memories. Okay, so and then if you guys want to share your project, just go to public, then save changes. Right, so you can see here 3 minutes ago your project is public, and you can go back again, tinker it again, or if you guys want to play it again, so you can see the description is a game for user to train their memory. Okay, this is the link for you guys to actually share it with your friends. Right, so you can also tinker it back, which is if you guys want to play it again and again and again, and also share it with your friends so that they can also create their high score, so just compete with each other, so that we can see how our brains can memorize things. Right, so you can see the project is actually safe. And what about the coding? So close the component, the coding, so all the coding also be safe. Alright, so don't worry. Okay, so that's all from me, guys. I hope you guys can enjoy my project. You guys can do it on your own, and I don't know, maybe you can just add more features to it so that it may be more fun. Okay, so try it and then share it with others if you guys can. So I hope you understand this project and play it and have fun, and thank you.